Hi, this is Craig Stocks. I'm here today for Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And I want to talk today about a collaboration project I did with Antoine down at the Galactic Hunter, imaging the Seagull Nebula. It turns out we're kind of neighbors. He lives about 2 hours south of where I live. So we got together and decided it would be fun to process the same data, each using our own process. He, of course, using PixInsight, which he is very well versed in, and I'm comfortable in Photoshop, so I elected to go that route. So first of all, let's talk about the Seagull Nebula. It's actually a very large subject. This little chart shows a number of different targets, kind of popular features, and they're all the same image scale, and you can compare those to the size of the moon here in the center. So as you can see, the Seagull Nebula is many times larger than even a full moon. So it's a good target for a wide field refractor. If we look at it in Sky Safari, and this is showing the superimposed outline of the Takahashi FSQ 106 that I have, and it really fits very nicely within that wider field of view. The more narrow field of view here in the center would be if I were using the PlaneWave CDK 12.5, which has a much longer focal length and wouldn't work nearly as well for this target. In numerical terms, the Seagull is about 120 arc minutes across, and the Takahashi field of view is 223, so it fits very nicely within the Takahashi's field of view. So the first thing we did was go into the Voyager web interface, which I really like to use for setting up the field of view and determining how I want to frame the target. We can search for the target, get it centered in the field of view, and even adjust the rotation angle to frame the target just the way we want the telescope to frame it. And then when I run the sequence, I open up the observatory, turn on the telescope controls, basically launch the software, and the computer takes over, and at the appropriate time it will point the telescope at the Seagull Nebula, rotate the camera, and start the sequence of images. So this is just a quick look at the observatory where I do pretty much all of my imaging. It's in the desert in southwest Utah. We have typically Bortle Class 2 skies with seeing in the 1 to 2 arc-second range, so we have really good seeing. It sits at 5,100 feet elevation in a big flat mountain valley, and it's about 60 miles north of where I live. My daughter and her husband do live on the property, so we do have somebody local who can go out and if we need to turn something around or unplug a cord and plug it back in, whatever, I've got somebody on site who can do that pretty much 24/7. You can get more information from our website at utahdesertremote.com. So the hardware that we're going to be using for this image is the Takahashi FSQ 106 sitting on a Paramount MX Plus mount. I'm using a ASI 6200 mm Pro monochrome camera with a filter wheel with kind of the usual complement of luminance red, green, blue, sulfur, hydrogen, and oxygen filters, and there's an Orion mini guide scope sitting on top of all that. And it's kind of fun if you look at the picture here that I took last week. You can get a good view of the zodiacal light coming up through Jupiter, and that's a big dust cloud that surrounds the sun in the same plane as the orbit of the planets. And when you have good dark skies just after sunset or before sunrise, you can see that streak of light. And by eye, we could see it going up almost all the way to straight overhead. It's just amazing to look at. So once everything is set up, I go into Voyager, and the sequence that I was running was a combination of hydrogen, sulfur, and oxygen for 10 minutes each. And then I was also shooting red, green, and blue for 2 minutes each, and that was primarily for the stars. So that way I could use RGB stars and narrowband for the nebula. Once all the files were done, I load everything into Deep Sky Stacker, and I'll typically select the best hydrogen frame as a reference frame so that everything is stacked relative to that one frame so that everything is aligned properly when I load them into Photoshop. And in this case I wound up with 19 HA, 19 oxygen, and 15 sulfur frames, and those were combined then with 7 red, 6 green, and 5 blue, plus flats and darks to give the final image. And then the narrowband images, I use an arc sign stretch in a program called Fits Liberator to stretch the narrowband images. It has a number of different stretching algorithms built in, but I really like the arc sign or inverse hyperbolic sign function. You've got some controls on the histogram to control the black point and the white point, and I try to find a nice compromise between having the background too dark and blowing out stars, or a lot of times I'll find a double star that I can zoom in on and adjust the white point so that I can still see those individual stars. And then from that it's ready to go into Photoshop, and I have basically 6 files to work with. The 3 narrowband TIFFs from Fits Liberator in hydrogen, oxygen, and sulfur, and those you can see here on the side. And then the 3, I just used the autosave.tiff files from Deep Sky Stacker, and that gives me red, green, and blue for the stars. So with that, let's jump into Photoshop and talk about the image itself. And I have to tell you that this has been one of the images that I really struggled with. It seems like some targets, some images just fall out of the camera ready to share, and others seem to want to fight you every step of the way. And this one was one that I really struggled to try to find a good combination of pleasing colors, but also that showed the structure of the gases, because there's a lot of real nice detail in the gases, especially going down I guess it'd be the right wing of the Seagull. There's a lot of oxygen in the center, in the heart of the Seagull, and a lot of sulfur, especially in the shoulders and in the head. So I wanted to maintain that distinction between the different gases and also have something interesting and pleasing to look at. And this is the one I wound up sharing with Antoine when we kind of did our reveal with each other. Had we done that a day earlier, it would have been a completely different image. So I just wanted to talk about some of the decisions I made and how I went through this. And if you've seen any of my videos before, you know that I like to do everything in Photoshop working from layers rather than from channels. I find that to be a lot more flexible, and nothing is ever really cast in bronze. Any change that I make, I can unmake or make a different decision. And let's just explore a little bit. The layer stack is fairly typical for my images. At the bottom I have layer groups for hydrogen, oxygen, and sulfur. And within each one of these groups, if I open up I'll open up the hydrogen. And at the bottom of that group is the starred layer. And if I alt-click on the eyeball, we can look at just that layer by itself. So that's the hydrogen layer with all the stars intact, pretty much the way it came out of Fits Liberator. And then if I alt-click on the eyeball again, that will turn everything back on the way it was. If we look at just the starless version, which is sitting right on top of it, this is the hydrogen with the stars removed. And I really love the detail, the flowing gases and the highlights and shadows and texture here. And that's something I didn't want to lose when I went through the process. I mean, it seems like the more colors I add and the more things I do, it was harder and harder to maintain all of this detail. So, in a way, it's tempting to just go with a starless hydrogen version and really enjoy the glory of all that gas. So I'll click on the eyeball to turn this back on. So that's typical of each one of the stacks. Then I have a levels adjustment to adjust the dark and light points of the layers that are in that group, which in this case would be the starless hydrogen layer. A couple layers where I selectively lighten and darken different areas, and then a final levels adjustment to adjust the brightness of the highlights and shadows of the hydrogen. So each one of the groups is going to be structured similarly, and I use the channel controls in the advanced blending options to turn individual colors on and off. So for instance, if we look at the sulfur group, since I have this mapped as an OHS, or oxygen, hydrogen, sulfur, for sulfur it's going to be mapped as blue. So basically I just turn off the red and green channels for that group. All that's left is blue, so sulfur represents blue. And then on top of that I have some global adjustments, color balance, hue saturation. Near the top of the stack I have a layer that is just an almost black layer with some noise added. So this is about 25, 25, 25 in terms of RGB values, so almost black but not quite, and a little bit of noise added. And I have that in lighten blending mode. And what that does is it adds some brightness and some noise so that it doesn't look artificial, to even out the background. So without that, you'll notice that some of the background areas are going to almost pure black. There's really nothing of interest there. I just want it to be nice and smooth and fit with the rest of the image. So this dark layer in lighten blending mode just kind of lifts up those areas that are too dark and smooths everything out. And then the last group on top is the stars. If I turn that off, we have a starless version. And while I don't normally like starless images, this one, because of all of the fine detail in the gas, the stars really seem to kind of obscure that. And by going with a starless version, you really get to see a lot more of the detail. So if I think about other ways I might have mapped this, just for fun, let's turn off these intermediate adjustments, and let's just explore what if. What if instead of an OHS we had mapped this as an SHO? Well, I can just go to my sulfur group, and instead of having it in blue, I'll have it red. So SHO, sulfur, would be red. Oxygen, we want to be blue, and in this mapping it was red. So basically we're swapping the red and blue, or the hydrogen or the sulfur and oxygen. And I'm just double clicking to the right of the name here, and that brings up this advanced blending options dialog box. Again, I'll turn off the red, turn on the blue, click OK, and now we have an SHO, or Hubble palette color mapping. There's a fair amount of red coming in around the behind the head of the Seagull, and that's from the sulfur. If I feel like one of the components is too strong or too weak, I can go into that group, go to the levels adjustment within that group. So in this case I'm adjusting just the brightness of the sulfur. If I want to have it be less or more prominent in the background, I can adjust the black level. Basically tweak how it's represented in the overall image. And so now we've just switched this from an OHS version to an SHO version. The stars are still there if I want to turn those on to see what it looks like with stars or without stars. And if we want to tinker with the colors, we've got all these opportunities for global adjustments, such as the color balance, global levels, hue saturation, and so forth, to continue tweaking this. So, to me that's not a bad version either. I might do a color balance and just adjust the overall color balance a little bit to try to find a color balance that, again, is pleasing, but also shows a lot of color contrast between the different gases. We might play with the hue and saturation. Let me just reset this from whatever it was. If we want to increase or decrease the saturation, we can play with that. If we want to kind of rotate the colors, You can do that within hue and saturation and play with different color balances, find other ways to explore the colors. So that's kind of the process I went through. I still would say I don't have a version of this that I'm really happy with. I'm not unhappy with it, but it's just not my favorite image. I haven't really bonded with it. And so I will probably continue playing with it, and hopefully one of these days I'll find a version that just really sings for me. In the meantime, I hope you found this useful. Be sure to check out the blog post on Galactic Hunter, and I think he's going to have a video coming out soon outlining his approach to the project, so be sure to check that out. If you like this video, be sure to like and subscribe, and I'll keep more of these coming. And in the meantime, I hope you have a great day today and an even better night tonight under a clear sky. Thanks. Have a great day.